Alright, this lesson is over logarithmic functions. Logarithmic function. Logarithmic functions. Alright, so first of all, what is a log? A log is simply an exponent. Logs are exponents. Alright, so get that in mind. Alright, so when we have y equal, alright, let's say it like this. Y equal log base a of x. What that is saying is an exponent is equal to log of some base of some expression. Alright. Now, this base the base must be greater than 0. Alright. Must be greater than 0, and it cannot equal 1. Alright, so the domain of logs is all you do. You take your expression to find the domain. You take the expression and set it greater than 0, and then solve for the variable. Alright, so we're gonna do some quick conversion factors. Alright, we want to convert from logs to exponentials. In a previous video we talked about exponents, rules of exponents. Alright, so we're gonna go through some conversions. Alright. Alright, first we want to convert exponentials to logs. Exponentials to logs. Example. Trying to get y'all a different color. Let's say we have 1.2 to the 5th equal m. First thing first, identify the exponent. We see that the exponent is 5. The base is equal to 1.2, because just recall from exponents, you have, if you have an exponent, recall you have base a raised to your exponent equal to an expression. Alright, so all we do is change that stuff up and add a log in there. So your solution would be log base 1.2 of your expression is equal to 5. And that's it. Excuse me. Now let's do another example. Let's say we have e to the b equals 9. All right. Identify what the exponent is. The exponent is b. Identify the base. The base is e. And the expression would be 9. So your solution in this conversion, log base e of your expression equals 9 of 9 equals your exponent. Logs equal exponents. Don't forget that. Now let's say we want to work in reverse. Say we want to convert uh, logs to exponents. All right. And we have the given log is log base a of 4 equal to 5. Again, we ain't gonna change our beat. The exponent. What does the log equal? The exponent. So this log expression right here, this entire log expression equals this exponent. So our exponent is 5. All right, the base is equal to the base of your log is a. All right, so we have everything that we need. We have our solution, a to the 5th is equal to our expression of 4. And let's do one more example of this conversion. We have log base, let's say log base 6 of capital B equal -3. All right, so the exponent, identify the exponent. As you said, whatever is equal to the log, you are correct. Our exponent is -3. Identify the base. The base of the log is 6. Solution, 6 to the -3 equals b. Excuse me. And then we'll go through some simple breakdown examples where we want to find the exact value. All right. And so find an exact value of this. We'll save that for another lesson. How about that? Let's finish these little introductory rules. We have natural log. Natural log, most people call it ln, aka ln. Natural log has base e. All right, so when you have y equal natural log of x, like it just changes up the whole thing. Like it won't be written as base. It's just you're supposed to know it. Uh, to give you a visual, it could look like y equal log base e of x. That's basically what natural log is saying. It just don't write it out like that. The proper format for writing out natural log is using the ln function, not this. Okay, and so, but we know that natural log has base e, and then we have common log. Common log. Common log has base 10. Base 10. And normally you won't see a base written on common log. You just see y equals log of whatever your expression is. Alright, and it's understood, if you don't see a base there, it's understood that it's base 10 because that's common log. Alright, and then to note, alright, the only way these things right here can be true, this is true if all this is writing out a conversion. If e to the y, which is the exponent, equals the expression. This is true if 10 to the y equals that guy. Alright, so let's solve some problems and get out of here. Alright, finally, solving some equations, and we'll solve log equations, and you will solve these by converting. Your first example, you have log base 2 of 2x plus 1 equal to 3. Alright, so we're going to convert. Alright, what's your base? Your base is 2. What's your exponent? 3 equals the expression. So we have 8 equal to 2x plus 1, and that gives us final answer of 7 over 2 is equal to x. Alright, that's that conversion. Alright, and you can plug your answer back in to make sure, into this portion to make sure that whole thing is greater than 0. Yeah, but that will be. And then your next example, you have log base x of 343 equal to 3. Alright, and convert. Base is x, exponent is 3 equal to 343. Undo a cube power by cube root. X equals 7. And let's just throw one more in here for good measure. Let's say you have 2 3x equals 6. Is that exponential on that side of the equal sign by itself? No, it's not. So we're going to get it on that side by itself. So we have, get out of the way, e to the 3x equal to 3. E to the 3x equal to 3. Now, what log function do we know that has base e? Natural log. Alright? So we'll take the natural log of each side. After taking the natural log of each side, natural log and e, they're inverses of each other, so they undo each other, and the only thing that's left is 3x. 3x equal to the natural log of 3. Divide each side by 3 to get x by itself. And we have x equals the natural log of 3 over 3. This is an exact solution. Alright, and we'll call that a wrap on the introductory portion of log equations, well, log functions. Alright, see you next time.